Let's talk about writing equations of parallel lines. In this example, we are asked to write the equation of a line that goes through a particular point and is parallel to another line. When you're writing the equation of a line, there's two things you need to know. First thing you need to know is where it's located, and the second thing you need is what it looks like. To figure out where it's located, we need a point that is on our graph, and we're given that. Our point is -2, 5. The second thing that we need is to know what your line looks like, and that is found from our slope. But notice in our question, we're not given the slope. Instead, we're given the information that your line is parallel to some other line. Well, what we know about parallel lines is that they have the same slope. So the slope of my line is going to be the same as the slope of this line because they are parallel. Let me look at this equation then, which is already in y equals mx plus b form, and find the slope. I'll compare it to y equals mx plus b, and I notice that in the m spot is a -4, meaning the slope of this line is -4. Now that's the slope of this line. That's not my line, but my line is parallel to this one, which means that my line is going to have the same slope as this one. So if this slope is -4, so is mine. And now I have everything I need, so I can go ahead and write my equation. There's a couple different approaches I can take to write my equation. The first is to use what we call point-slope form, and that is helpful when you have a point and a slope, which I do. Point-slope form looks like this. And to use it, we usually replace our slope in the m position, and then your ordered pair for your point, fill in the x1 and the y1 positions. So I leave my y, and in the y1 position, I'm going to put the y value from my ordered pair, which is a 5. M, my slope, is -4, x minus, and then in my x position, I put the x value from my ordered pair, which is a -2. Notice I do have a double negative. Two negatives make each other positive, so instead of that double negative, let me just write x plus 2. From here, I will distribute and write this in slope-intercept form. I add my 5, and y equals -4x minus 3. So this is my equation in slope-intercept form. Now let's look at a second approach. When we're writing equations of lines, generally we want our equation in slope-intercept form, which is what I have here. Slope-intercept form is y equals mx plus b. I already have the slope of my line, which is -4, so I can at least fill that in, but I don't know what my b is, or my y-intercept. But what I do know is that whatever b value that is makes this equation true for any point that's on the line. Well, I know one point that's on the line, and that's the -2, 5 that I have above. So let me replace x and y with the -2 and the 5 and figure out what would b have to be so that my point is on the line. I put 5 in the y spot and -2 in the x spot, and I will solve for b. So b is -3. Now, a minute ago, I had half of my equation done. Up here, I had y is -4x plus b, and I didn't know what b was, but now I have b. So let me take b, put it back into my equation here, and I will have the equation of my line. Y equals -4x plus a -3, but if you're adding a negative number, that's the same as just subtracting. So let me write -4x minus 3. And you'll notice that this is the same thing we got when we did it a second ago. So you have a few different options available to you. Hope that helped. Thanks for watching, and I'll see you next time. Bye.